So what we're going to look at is Pyspark, and the main focus will be on PySQL. So how can you process big data using Pyspark and SQL? For us to do this, we'll have to find a dataset that is big in size, let's say 2 gigabytes and above. And we'll need to maybe see if we can get one from GitHub. So let's head over to github.com and search for big data. So we'll need datasets that are big in size. So big data, we'll need a file size over here. Trying to get one. Or instead of that, we can maybe try find one from Kaggle datasets. Then I can search for filters. Then it should be a CSV file. Then minimum size should be, let's say that 1000 MB in size. Let's see if we have one. We don't have a dataset greater than that. Let's search for that. Yeah, so we've got this file over here that is 119 gigabytes in size. So let me open Colab first of all and confirm if we can load such a big dataset using Colab. If not, so create a new notebook. I believe the max size that we have for Colab is 100 GB. So I'll have to reduce that based off those constraints. I'll connect. And I'll check my limits over here. So we've got 62 GB available. So let's pick a data set that is maybe 20 GB in size. So let me find one. So for 20 GB, it should be that. Apply. Yeah, so this is a data set that is 20 GB in size. Let me see one that we can use. We've got this digital typhoon dataset. So this is weather data. Let me see what it has. Not actual data that we can with well. Open FWI preprocessed 72 by 72. What is this data all about? We can't take that. Let's try find another data set that we can use. Yeah, ACI IoT traffic data. We've got the README, and then over here we've got the actual CSV file. Okay, so this is a data set that we can work with. So it's 625 MB in size, not actually what we'll need. Let me see if from my Google Drive I've got a dataset that is big in size as well. We've got this other one that is 5 gigabytes in size over here, and we can download it from Colab directly, so I'll show you how you do it. Uh, Ask Gemini. I can't seem to find that data over here. So what we'll do is we will just work with what is available over here. So before we load in big data, let me just take you through the basics, and then we can try out the the other stuff later on. So for big data, what we are going to be using is Pyspark. Let me not overcomplicate things. I'll share this notebook with you. You'll have access to the code that I'm running. I'll share it with you in the chat. And then what I'm going to do is I'm going to use a sample dataset that I've used today in class. And that should be this data. So this is the data that we are going to load. So I'll share that URL with you in the chat, and then we are going to add that over here as well. So I'll run that. And then what we are going to do is we are going to start our coding process. So for this coding process, I'll be using the Pyspark documentation as our reference node. So I'll head over to Pyspark. I'll open the spark.apache.org link. And then over here, we've got the getting started part. Okay. So we've got the installation. So if you're going to run Pyspark on a local machine, you can run it using pip install Pyspark. And if you want the extra dependencies, then you'll need to import these other dependencies as you have been shown over here. And then we've got the quick start part, and this is where we are going to start. So the first thing that you usually do is you usually create a Spark session, and the Spark session will allow you to load in data, do all those manipulations and all that. So I've copied that code, I'll paste it here, and then I'll add some comments over here to explain what we are doing. So the first step is always to import Spark session. So import and create a Spark session. So this is the import. Let me move this. And then this is the part where we create the session. So this is the Spark session. So we will have from pyspark.sql import Spark session, and then we instantiate our session. So this is the session name. So Spark session.builder.get or create. So if you had a previous session that you had created, you could import it in here. Okay. So if you check the documentation of this function that we have over here, just a minute, let me highlight it. Just a minute. If we highlight it, this is what we see. So you can see we've got this Spark session.builder master, so it should be local app name. So for example, this is the name of the app that you're going to create, so that just in case you've got a session that you had created earlier and you gave it a name, for example, word count, you can pass in word count in here directly, and then it will connect to that session. So this is a deep documentation on it. But what I've typed in here is just a simple version of the same. So I'll run that. And after we've instantiated our Spark session, the next thing we need to do is we need to load in our data. So to load in our data, we should have that here as well. Getting data in and out. So this is the part. So for Spark, this is how you get in data. So to load in data, you'll have spark.read.csv. Then you have to pass in your CSV file over here. So over here, I'm going to say URL, and then this will load. This will load in our data. Okay. So we can maybe give it a name and say this is spark underscore df, and spark df should be equal to spark.read.csv. We pass in our URL, so this is where our data is stored. Header should be equal to true, so this means that our CSV has got headers, and then we can remove the .show part over here and we will add it elsewhere. So we're going to have spark underscore df dot show. So this is where we will show our sample data frame, and you can pass in how many samples you want to see. So for example, we can say we need to see only 3 samples. So I'll run that. It's a little bit similar to pandas. So it has raised an exception error. So it means that we are not able to extract these data from, we are not able to extract that data from GitHub. So let's use pandas first of all to get these data stored here, and then we can import it directly from Colab. So we'll have import pandas as pd, then df should be equal to pd.read underscore csv. Then we're going to have our URL. Then we can have df.head. So this is our data frame. Then we extract it and save it as a CSV. So we're going to have df.to underscore CSV. Then we are going to give it a name. So I'll say maybe sample underscore data dot CSV. We run that. If I check over here, we've got our sample data. Then what I'll do is I'll copy the path for the sample data that I've now created. If we run that, we should have no issues. So we should be able to see this data that we have saved. Yeah, so this is what we have. Let me see if we can do anything on the index column. So we've got an extra index column over here, which is not that big of an issue. So you can code this and then we can proceed on in the next 2 minutes. So I want you to understand how Spark works. So first of all, you import Spark session, then you connect your Spark session, then you go ahead and load in your data. So in this case, our data, we'll load it in similar to pandas, but you can see it's a little bit different. So the syntax is just off a little bit. So instead of read underscore CSV, we've got Spark. So actually this is the name that we instantiated up here, and then .read.csv instead of read underscore CSV. So that's how we work with Spark. So 2 minutes, you copy that and then we can proceed. One more minute. Let's proceed. So once we've created our Spark DF over here, you can manipulate that data using SQL. And for you to manipulate that data using SQL, first of all, you have to create a view for your table. So I'll copy this code and then we are going to paste it in here. So we're going to have, so here it's supposed to be Spark underscore df dot create or replace temporary view, and then here we'll need to give our table a name. So over here I'll call this cardio because this looks like a cardio data set, and then this will be our temporary view. So I'll add comments over here on what we are doing over here. So create a temporary SQL table view for the data. So this is how we create it, and then we can run that. And then as we proceed, there is a way in which we can write in our queries. So this is the recommended way in which I will recommend you write in queries, okay? So if you are trying to query in your data and do data manipulation using SQL, so I will recommend you type in your query this way. So you can have query being equal to, then open the triple quotation marks, then type your SQL query here, and then close that triple quotation marks. So this is the syntax. And then what you are going to do is you are going to have spark.sql, and then in here you pass in the variable query, and then you can have .show to see the results if you want to. So this is the way in which we are going to do this. So let me copy this, share it with you in the chat, and then we can do some queries here and see what we can manipulate in this data. So 1 minute to complete this part and then we can proceed. Okay, let's proceed. You should be done with this part. So we are going to start with our first query. For example, we will need maybe the, so what will we need over here? So let's say maybe the count of males and females in this data. So here we will start by typing in our query. So we can say this is query number 1. And for query number 1, we are going to have select, and then we are going to have count, or let's say we have to pick gender first. So select gender, comma, count, and bracket start from, and then we are picking these from cardio. Then we'll have to group by gender. And then we'll close this quotation mark, and then we are going to have spark.sql, and then we are going to pass in our query, that is query number 1, and then at the end we are going to have .show. So this should show us the count. So for count star, we will have count star as let's say the count, and then we can run this. And over here, you get an output showing you how many females and how many males are there in the dataset. So you can see, instead of running Python code, we are actually running SQL queries. So this is expected to be a little bit fast compared to pandas data frames, but it's not always the case, because in here, in this case, you can see we've got 2 seconds. And if I was to do the same for the pandas data frame, so we have df, so df dot group by, and then we are going to have gender dot count. You can see this literally takes less time compared to what we have over here. But if it was running a task that was a little bit complex, let's say pivoting this data, running this SQL code will be considered to be fast as compared to you running this pandas code. So let me delete that. So this is how you type in your queries. So who can suggest another thing that we can check over here from this table? You can type in chat a suggestion of any statistics that we can get over here. Maybe the average calories burned per gender. Let me do that. I'll copy this, and then we'll have query number 2. So we need the average calories burned. So here we will have AVG for calories as average calories. From cardio group by gender. Then these we change to query number 2. So this will show you the average calories that are burned per each gender. So for females, it's 88. For males, it's 90. Query number 3, who can give us a suggestion for query number 3? You can type your suggestion in chat based off this data. So what do you think we can, what statistics can we extract from these data? Any suggestion? So let me type in one complex SQL query, and the rest you can try. So for query number 3, it's going to be a complex SQL query. So we're going to have spark underscore df over here dot show. For me to see what we have, so I'll show just one observation, and then I'll use this for reference. So what I'm going to do is I'm going to type in a query that is a little bit complex. So we will have select, we can select the age of each individual. Then what we are going to do is we are going to round off at the average, and then we are going to round off the average duration of the cardio, and then we'll need it in 2. So we are rounding off to 2 decimal points as average duration, comma. Then we'll need to round off the average heart rate. So we'll need to know for each age uh, what were the averages for the duration of training, heart rate, and all that. So as AVG at rate, comma. Then we'll need a maximum. So this is the maximum calories band. So maximum calories as max calories. What else can we add over here? Then we're going to round off and do some bits of calculations over here. The average, so we'll need the average weight of each individual divided by the power of height. So height, we are going to divide it by 100. And then we'll need 2. So we've got that, and then this is rounded off to 2. So this is supposed to give us the BMI, okay? So as average BMI, and then lastly, what we can do is we can specify where we are getting these data, so from cardio, and then we group by age. So we can do some filtering actually. So we can say where gender is equal to male. So male is in small letter. And then we can group by age. So the only column that doesn't have any calculations, okay? And then here we are grouping in by gender. We can add another filter. We can say something like, and age is less than 50, because we know for a certain population, we've got more individuals below 50, or let's say above 65, because this will give us even less data points that we can have a look at and verify. So group by age, then we are going to order this by the, what can we order this with? We can order this by the max calories. We can have max calories descending. So that's our query. So over here, we are going to pass in query number 3. So the part that might give us issues is this part, but let's first of all run the query and see if it works. Okay, so name heart rate, supposed to be heart rate. Yeah, so this is our table. You can see the calculation was actually fast at 2 seconds. So we've got the different ages. So we've got age 66, 77, 69, 71, 74, up to 72. And this is the average duration. So we should actually order this by age first. And then the max calories. So we've got 66, 67, 68, 69, 70. Actually, max calories over here doesn't make sense because we've already ordered these by age, but this is what we have. So you can see for age 66, these are the results. So once you've gotten these results, we can save them in a data frame and then we can plot them. So these are your results. So if we type in .show, that's what we have. And then what we can do is plot, we can plot the results. So we'll need to import matplotlib, and then we'll need to convert this to our pandas data frame. And then over here we'll have plt dot figure, and then we specify the fig size. Let's say maybe a 10 by 6. And then we are going to have df dot plot. We are going to have maybe the plot for age against the average duration. We label average duration. We can have another plot, plt dot plot. We can have all these. So we've got average duration, average heart rate, maximum calories, average BMI, and then we add our label, title, legend, agreed, and then we show the plot. So let's run that. So this is our table output, and then these are the results. Actually, let me remove the grid because I guess it's interfering with the results that we are getting here. And this is what we have. So you can see we've managed to split these, to pre-process this data using SQL. And then after we've pre-processed that data using SQL, we've converted it into our pandas data frame, and then we've done the plotting using matplotlib. So this is basically how you're supposed to deal with big data. You analyze and simplify it using SQL, because SQL is, I will say SQL is more powerful as compared to Python. Because if we search over here, SQL versus Python for big data, this is what we have. So SQL is best for managing and querying structured data with rational database, while Python is more versatile for data analysis. So SQL should be your go-to tool when you are dealing with databases, okay? But Python is not that efficient when it comes to pre-processing data that is big. So that is how you work with queries on Pyspark. Anyone with a question on that part? Yeah, so we've got the average weight per age. I've created that. Anyone with a question on this part so far? I know you are amazed to see us running SQL queries on Python. Any questions? Yes, Daniel. No, there are only these two ways of manifesting data using Spark, and it's using SQL and Python, or there are other ways. There are other ways in which you can manipulate these data. So this is just an example that we have. So we've got other tools like Hadoop, but that is different. So you can see it's an open source software framework that enables distributed storage and processing of large data sets. So this one is more complicated. I will say I don't have any experience on this, but this is what we have. And then we've got the Apache Spark. Now what I'm showing you. So for Apache Spark, you've got the option for Python. What I'm currently showing you right now, you've got the option for PostgreSQL, where you can work with these on MySQL Workbench and all that. And you've got the option for BigQuery and all other storage options. Yeah, but this is what we show you in the course, because this will be a good starting point if you are going to maybe specialize in the big data field. Have I answered your question? Okay. Yes, Joanne? It will work on Streamlit also. So yeah, the same way we've done it here, it will be visible on Streamlit, but this code won't be visible on the front end. Yeah, something like this. Yeah, but let me check and confirm if we've got someone who has deployed Pyspark. When you're using editor, is it slow? Yeah, uh, it might be it might be your connection maybe, but yeah, yeah, servers. Yeah, so yeah, code space is not working completely for you. Sorry to hear that. You can work on with Streamlit offline, and then once you've got everything running, you can save that data to GitHub and then deploy. But what about your deployed web apps? Are they slow or? Oh, okay, okay. The coding part. Oh, okay. So the changes that you are making, okay, the changes that you have been making are not reflecting fast as you would like them to be. Yeah. If you found a solution that works for you best, then that should be okay. Because you can see for me, it's it has always been fast. I've never had any issues. Okay, so let me summarize some of the things that we've looked at today, and then that will be it for today. Because you can see this is the outline. So we've got the part for data frame creation. You'll never create new data frames using Pyspark because you are past the basics. Viewing data, I've shown you how you view data just using .show, and then selecting and accessing data. So this is something that you can look at. But if you can run SQL queries, then you don't have to run these functions, just work directly with SQL to do the filtering and all that. Then grouping data, just do the grouping with SQL. So working with Pyspark directly, data frame as it is quite hectic. And then getting data in, I've shown you how you can load in your CSV files. So we've got the option for CSV. You can load Packlet files and you can load ORC files. So these are the three different files that you can load. And then lastly, I've shown you how you can work with SQLs. So first of all, you create a temporary view, you create your queries, and then you query your data using those queries. So that should be it for today for these basics. I believe that covers the data manipulation part because you can manipulate data fully with SQL just as you do with Python. So the next thing that we are going to look at in the next class is machine learning. So how can you fit ML models using Pyspark? Yeah, so that's it for today. Maybe in the next few minutes, you can ask more questions if you have on what we've been looking at so far. Yes, Joanne? Yeah, so once I'm done with the class, next it's supposed to be an internal guided project, which I don't know if I'm the one who will take you through. It might be a team effort, so we might have different trainers assisting you on the project. I guess you'll be given, if you want, you can be given a whole month to prepare for the exams, but it's not hard. So it's practical based and actually not hard. So it's something that you can easily manage. Yeah, yeah, yeah. Yeah, you'll be given time, so you don't have to worry about that. Anyone else with a question?